Hey everyone, my name is Rowan de Hass, and today I'm going to be talking about deploying Stratis Smart Contract infrastructure to Azure Container Instances. I'm going to walk you through a bit of a demonstration about creating an NFT smart contract and deploying that to a Stratis blockchain. And then we'll create a microservice that combines the two different elements, an API backend that exposes information about our NFT that we've just created, and a Stratis node that provides this information directly to our API backend from the Stratis blockchain. So let's get started on this in just a second, but before we do, let me tell you a bit more about myself. I am a C# developer, and I really love the language, the tools, and the community and the ecosystem that surround C# and .NET. So I've been working with C# for a long time in an enterprise context until around the year 2018, when I became interested in blockchain and smart contract development. Now, at the time, there were no C#-based blockchains, and there was no way to write a smart contract in C#. There were definitely no .NET blockchain tools. So I pretty quickly discovered Stratis and their goals of building a blockchain node in C#. And I eventually ended up joining the team who built the Stratis Smart Contract platform module for the .NET full node. Eventually, I was able to realize my goal of being able to write a smart contract in C#. So the Stratis platform itself is an open source blockchain that's written entirely in C#. And by design, it is modular and extensible, and it allows different blockchain components to be connected together in whatever ways a developer desires. It could also be thought of as a blockchain SDK, where you can kind of pick and choose different consensus algorithms, different databases and storage mechanisms. And then on top of that, you can add features like smart contracts to come up with entirely new blockchain configurations. So the software behind the Stratis platform is used to power several public permissionless blockchain networks. The first of these is the Strax network, which is the original network that's secured by proof of stake consensus. And the second of these is the Cirrus network, which is a sidechain to the Stratis network and capable of running smart contracts and is secured by proof of authority consensus. There are also testnet variants for these networks, which are places where you can play around with the Stratis blockchain without using real funds. So whenever I refer to the blockchain in this presentation, I'll be talking about the Cirrus test network, which is where we will be deploying our NFT smart contract. So let's get started creating our NFT, and it might help to have some context on what an NFT is. So I'll run through a brief overview of that now with a couple of examples. So right now, a digital art craze is sweeping through the world, and we have artists, developers, and even auction houses creating and trading unique digital art, and it's all being done through NFTs. The technology that makes NFTs possible is smart contracts. So almost everyone who has used the internet would have seen this image at some point. This is the Nyan cat, and the Nyan cat was recently turned into an NFT by its original creator, artist Chris Torres. But what exactly is an NFT? Well, the letters NFT stand for non-fungible token. And by now, everyone's probably familiar with the concept of a cryptocurrency token. Ordinarily, when you own a token, it has no particular identity attached to it, and it could be swapped with any other token of the same kind. You own the token, but you don't really care which particular one it is. And this property is called fungibility. So when something is not fungible, it has its own unique identity. For example, consider a rare painting, something like a rare Picasso. Because only one copy of this rare painting exists, it can't be interchanged with another painting. So due to its uniqueness and rareness, it is non-fungible. And we can extend this concept into the crypto space too, by creating tokens that have their own unique identity. And these tokens can represent many things. Things in the real world such as real estate, or even things in the digital world such as art. So it might help to think of NFTs in this sense as digital collectibles. All right, so hopefully with that background of what an NFT is, we're ready to kick off our walkthrough. So we'll start by creating our own NFT smart contract, and then we'll create our microservice and we'll deploy it onto Azure. Okay, so inspired by the Nyan Cat, I present to you this piece of digital art, the Ninja Cat. And shout out to the artists who created Ninja Cat for the Paint 3D software, because I have borrowed this sticker from Paint 3D. It is not an original, I am unfortunately not that artistically inclined, but I do want to turn this Ninja Cat image into an NFT and publish it on a blockchain. I've created a small piece of metadata to describe the NFT. It contains the name and the description of the image, as well as a reference to the URL where the image file is stored online. And it's a reference to this metadata file that will be permanently deployed on the blockchain. So the reference will be immutably deployed somewhere where anyone who wants to verify that the Ninja Cat image belongs to the NFT contract can look up this metadata and see exactly where it is stored. I've uploaded the image of Ninja Cat and the NFT metadata to Azure Blob Storage. This data now exists somewhere where I know it will be redundantly stored and geographically distributed so that it can exist indefinitely. And I set the blob access permissions to anonymous read-only access so that anyone else is also able to view the image and the metadata. So now that we've published our image and our NFT metadata, we can start to deploy our NFT smart contract to the blockchain. I flicked over to Visual Studio Code now, where we can see a JSON file that contains all the information we need for deploying our NFT to the Stratis Smart Contracts network. Down the bottom of the file, we have the code of our NFT smart contract, which is raw C# IL bytecode that has been encoded into hexadecimal. And next, we have the parameters for our deployment, which includes the name of our NFT symbol, and the reference to the metadata, which we just uploaded to Azure Blob Storage. So I'm going to copy all this and then paste it into the smart contract deployment endpoint of the Stratis full node. And the endpoint we want is this one here for building and publishing smart contract creation transactions directly to the blockchain. So I'll paste that in there and broadcast that transaction. And what we expect to get back is a result that contains the address of the NFT contract that's just been deployed to the blockchain. If I copy this address and scroll up a bit, we can use another endpoint to check that the code exists at this address. And what we should expect to see here is some, maybe the transaction hasn't been mined yet. So let's just wait a second for that to happen. Could take 1 or 2 attempts. And there we go. So what we see here is the name of the token that we've just deployed, the name of the type. And then we see the raw C# bytecode in hexadecimal format. But we can also see the decompiled C# of our NFT token smart contract. So that's our deployed NFT token. So now that we've deployed our NFT and we know that this information exists on a decentralized public blockchain, we want to be able to share this information with others, for example, in a UI or front end. But how do we do that? Well, one way would be to have our users run their own instance of a blockchain node, which they can then connect to our UI. But that isn't always practical. Not everyone has the time or the resources to set up and synchronize a full blockchain node, and this stops being a viable approach entirely when taking mobile devices such as smartphones and tablets into account. But there is a solution. We can do the heavy lifting for our users, and we can make our NFT information accessible via a REST API. To do this, we will need to host both the blockchain node and the REST API. But luckily, this is really easy using Azure Container Instances. We can deploy our NFT microservice to production with just one very simple configuration file. And another great thing is that we can commit this configuration file directly into our repo so that we can share it with our team. In that way, our microservice configuration becomes code. Now let's take a look at how this can be done. So I flicked over to Visual Studio now. We can have a very quick look at our NFT REST API implementation. I started by implementing a basic controller which will return details about an NFT at a specific contract address. The way it does this is by directly querying an instance of a Stratis blockchain node to get details we want to show in our API. And that happens in this method here, get NFT details async. Let's click into that method and have a closer look. This method will send off several requests to the blockchain node to query the name, the symbol, and the owner of the NFT. And it will then compile those into a single view model, which will be returned as a JSON object through our controller. So let's have a look at this in action by running the solution on my local machine. And I'm already running a copy of the Stratis blockchain node locally, so all requests will just go there. So here we have our API endpoint. It's working okay. What I can do is append our address of our NFT token contract to the end. We expect to get some details back. And we can see that we've got our NFT name, NinjaCat, and then we've got our symbol and the owner, which is my wallet address. So the next step will be to deploy this little microservice to Azure container instances. So there's two components to the backend microservice, and we just saw the first one, which is the NFT API. And the second part is Stratis blockchain full node. So ideally, we want to have Docker containers for each of these services so that we can bundle them together into a multi-container group that runs on Azure. So next, we need to create a Docker image for our NFT API. So when I created this project, Visual Studio kindly and automatically created a Docker file for me. So all we have to do is check this out, make sure it looks okay, and then build and publish it to an Azure Container Registry. But before we can publish it to the registry, we need to create the registry. So we can do that using the Azure command line interface. So let's have a look at how that is done. So we're going to use the command line to interact with Azure via the Azure command line interface. And let's create a container registry where we can push our Docker image. And we'll use this command as ACR create, and we'll specify a name, a resource group, and an SKU, and let that run. And when it finishes running, we will have created a private place where we can publish our Docker image. So it looks like our registry is being created successfully. We can check that in the Azure portal. Click on refresh in our container registries page, and we can see the Stratis API registry has been created. So now that we've got our registry, we can begin pushing our Docker image there. Let's flick back to our console window, and then we need to push our NFT API image to the registry. But before we can do that, we have to log in to the registry. And I always forget this step, but it's crucial. So make sure you log in. And once we've done that, we can start to build our Docker file. So the login has completed, and I'll just copy paste this command to build our image. Paste that in there, and this shouldn't take very long because everything is already cached on my local machine. There we go. One thing you will notice is that we have to give the image a tag, and we have to include our image registry name in the tag so that it knows where to go when we run our push. So let's run our push command, and I'll just paste that quickly in there and kick that off now. And this shouldn't take very long either. And then once it's completed, our repository or our container registry repository will have a copy of our Docker image. So once that's done, we can flick over to the Azure portal and quickly dive into our registry, scroll down to the repository section, and let's see if it's been created. Yeah, there we go. So we have our Stratis platform NFT API Docker image published to our container registry that we just created. So back in Visual Studio, we can go ahead and start working on our Azure Container Instances deployment file. And what I've done is created a YAML file that contains the information of our container instances deployment. So if we have a quick look at that here, we can see that we've got our Stratis blockchain node together with our NFT API. And we want to keep these two together and deploy them together to our container instances. To do that, I've created a multi-container deployment. So you'll see in this file that there's two definitions for containers. The first one is our blockchain node, and it uses an image which is publicly available on the Stratis Docker repository. So Stratis publishes images for both Stratis and Cirrus mainnet and testnet networks. So initially, I've had to give it quite a bit of resources because syncing the chain consumes quite a lot of resources. So I've had to allocate 3 CPU cores and 4 gigabytes of memory. And the next thing that I've done is to expose the API ports used by the node, the first port being port 38223, which is used for the API. And then the next port is 26172, which is used for the blockchain protocol. And finally, I've created a volume mount, and this volume mount will expose a persistent Azure file storage so that the data directory of the blockchain can be persisted permanently. So that means that if we have to recreate or restart our blockchain nodes, we won't lose all of the data that we've downloaded. And that can be on the order of several gigabytes of data. So it can be quite handy not to have to resync the full chain every time we restart or recreate our containers. Okay, so the second container in our container group is the NFT API. And that's the API and the Docker image that we've just created. And as we know, we've published that to Azure Container Registry, and we can point our configuration to its location in our registry. And because our API is fairly basic, we don't need too many resources, so we can just allocate a CPU of 0.5 and 1.5 gigabytes of memory, and that should be more than enough. And we also need to expose ports 80 and 8080 for our HTTP traffic. We could also expose 443 if we wanted to enable SSL, but we won't do that for our demonstration today. Lastly, we've got a couple more definitions here. We've got our IP address, and we've mapped our ports that will be exposed directly to the public. We've also defined our volume mapping so that we can actually map this volume on our blockchain node directly to our Azure file storage. And don't worry, I know that there's some secrets in this file, and I will be deleting these shortly. But other than that, that's really it. So it's actually quite simple and easy to create a multi-container group in Azure Container Instances. And it's really quite nice and powerful to be able to define these things in code and share this code with other developers in our team or with our clients and other users of our software. Okay, so next let's take a look at how to get this all set up and running on Azure Container Instances. So we have our multi-container group configuration file, and we can deploy it from the command line again. So I'll just flick to the command line again, and let's quickly check that we're in the same folder. There we can see our deploy ACI configuration file. And to deploy it, we just need to run a single command as container create. We'll specify our resource group. We'll specify the file name and kick that off. And while this is running, it will be creating our container group and deploying 2 containers within that group. The first container will be our Stratis blockchain node, and the second will be our NFT API. It looks like they've just deployed successfully. So let's open up the Azure portal and have a look. First, we'll browse to our resource group, look for our container instances. And our first container is visible in the settings. We can view both our containers actually. So our first one is the blockchain node that we created. So let's click into that and have a look at the logs. It looks like blocks are being downloaded, so everything seems to be running as expected. And our second is our API. Let's have a look at the logs for that. And that also seems to be running fine. So what we can do is we can go over back to our overview page and we can grab the IP address of our container instances and copy that into the clipboard. And then let's fire up a new window and we can navigate to our endpoint where we expect to see an OK response from our NFT web app. Okay, so looks like that's working fine. So what happens when we navigate here is that we make a request to port 80, which is then forwarded to our NFT API container, which has exposed ports 80 and 8080 to the public internet. And now it's able to serve up data from our NFT smart contract directly from the blockchain. All we need to do is plug in the address of the contract we created earlier. So let's paste that in there and we can see the information about our NFT. We've got its name, NinjaCat, its symbol, and we've got our owner, which is my address. And then what we could do from here is we could take this API microservice that we've created and integrate it into a front-end decentralized application or DApp, or let other people use it to build their own products on top of. So just to recap everything we've done today, which is quite a lot, we have created this magnificent piece of digital art, NinjaCat. And then we've turned NinjaCat into a digital collectible and published the image and the metadata about it to Azure Blob Storage, where we know it will exist as long as we want it to. Then we've created an NFT smart contract which contains a reference to this metadata, and we've published this NFT to the Stratis blockchain. And so that we're easily able to view information and share information about our NFT and consume it with other applications or UIs, we've written a small microservice to obtain that NFT data directly from a blockchain instance that we host. And we've done this by creating a multi-container group using a very simple configuration file, which we then deployed to Azure Container Instances. So I hope this has been entertaining and really shown you the power of Azure and Azure Container Instances. It's super easy to set up, deploy, and share new kinds of infrastructure that's easily reproducible for both your team and your customers. All you need to do is share with people a couple of configuration files and they can replicate it themselves. Thank you for listening, and feel free to jump on the Stratis platform website where you can drop us an email with any questions. Or you can find all the links to our social media platforms where you can stay in touch and follow what we're up to.